Hi, Mr. Stride here. We're talking about polymorphism. It's it's a hard thing to understand. It's where one thing can be many things. All right, never mind. Let's just get right down to it. What it means is that code, it's so hard to explain, does different things when you want it to do different things. You can have the same code do different things. It's so weird. Okay, if you want a cat to act like a cat, well, it's going to act like a cat anyway. Oh, shoot. I just don't even know. Let's get into the code and review this some more.
Nope, no code here. I'm such a liar. Okay, we're going to review casting. Is-a and has-a, we're going to discuss what that is. Yeah, that's weird. And we will talk about polymorphism because it's hard. So what are we going to talk about? We're going to do casting and polymorphism. Hopefully we're going to get them more solidly understood so that you can see where casting implicitly happens, and you'll be able to know what type of errors occurs when you do casting incorrectly, whether it's compiler or runtime exceptions. And then we're going to know when to choose is or has a relationship in your class design, and where in there is polymorphism. Well, polymorphism is pretty much all of this all of the time. It's a hard thing. We're going to talk about it some more. I promise there'll be some code examples in here. Stay with me. All right. Remember how we have cat and dog baskets? In a cat basket, dogs don't get to go into it. We're going to keep talking about that. You just got to remember the analogy that identifiers are like baskets. And if you have a dog identifier, then no cats get to go into it. But we can have a pet basket, a pet identifier, and you can get both cats and dogs in there, okay? And we're going to be using dogs and cats and pets as we talk about this some more. And I want you to take a close note of the arrows, okay? The dog points to the pet, the cat points to the pet because a dog is a pet and a cat is a pet. So it's important to know those arrow relationships, as we can see that you can put a dog into a pet identifier, okay? So let's take a look at the problem from a compiler's perspective. I have a new dog that I'm creating. I'm not going to give it any parameters here for the time being, okay? So let's just say that new dog without a name in there is going to be just fine. So can I stuff a new dog into a pet basket? Can I do that? Yeah, you can, because a dog is a pet. And what happens right here, you don't see it, that there is an implicit cast right there. We are casting this dog to a pet, and no error happens at all, okay? It just fits right in there, no problem. So now we look at this next line. I have Odie, which is a pet, which actually, it's a dog, but it's in a pet identifier, and I'm casting that to a cat and trying to stick that in. Can you do that? Are you going to get an error? Will that work? Whoa, this compiles. Wait a minute. The compiler trusts you, okay? Because it says, all it knows when it gets to this line, it says, this is a pet. And I know that some pets are cats, right? Some pets are cats, so this could possibly, I don't know, somewhere along the line, have been a cat once upon a time. And even though you're the smart coder and you said it's a dog, and you stuffed it into a pet identifier, you basically fooled the compiler to let you do this. However, when you run this code, you get a runtime exception because the runtime knows for certain that Odie is actually a dog, okay? So that won't work. You get a runtime exception because a dog is not a cat, okay? A cat is a pet. How about this next line? Can you take this new dog and cast it to a cat? What kind of error are we going to get there? Well, oddly enough, when I try to take this new dog and cast it to a cat and assign it to the cat oddly enough, that doesn't work because a dog is never a cat, and the compiler says, hey, look, I know you're a dog. You're on the same line. What a dog. Don't be a dog. I know you're not a cat. I'm not going to stuff you into a cat basket. So that doesn't even work with the compiler. It doesn't work with an implicit cast. It won't work with an explicit cast either. This is an explicit cast. It just completely fails. All right, so down at the last line here, we have animal equals, this is Odie. Odie, a pet. Will that work? Can I stick Odie the pet into an animal? Yes, because a pet is an animal. It's always an animal, no matter what. No explicit cast, no implicit cast happens for you. Explicit casting is option. This gets through the compiler and it gets through the runtime with no errors whatsoever. All right, let's practice this, okay? There's implicit casting going on right here. Will it work? I want you to tell me whether it's going to be okay or whether we're going to compiler error or we're going to get a runtime error, okay? As we step down through each of these lines here, can I take a new cat and stuff it into a cat basket? Yeah, that gets through the compiler and it gets through the runtime. Can I put a new dog into a pet? Yes, because all dogs are pets. You can put a dog into a pet basket just fine. Now, can I stick a pet into a dog basket? No casting, right? No casting here. Can I stick a pet into a dog basket? Compiler error, okay? Because not all pets are dogs. It might be a cat, might be a bird, could be a snail, okay? You don't know what it's going to be. But the compiler doesn't know, and it's not going to let you do it implicitly. You could explicitly do it, though. Can you put a new cat into a dog basket? Compiler error. All right, a new cat explicitly cast to a dog and into a dog basket. These are weird things. No, you can't, just like we saw in the previous line, because the compiler knows that a cat is not a dog. It's not going to let you cast it. Okay, what about here? P1, which is a pet identifier. It's a pet basket. So P1 is holding a pet of some kind, and we know it's holding a dog. Can I explicitly cast it to a cat and stuff it into a cat basket? These are really strange. You get a runtime error. So the compiler says, hey, all I know about P1 is it's a pet. And some pets are cats. So I'm going to let you do this at compile time. But the runtime says, I know that P1, pet 1, is actually dog. So you get an error there. Okay, so I have C1, which is a cat. Can it scratch furniture? Yeah, it can. Okay, because a cat scratches furniture all the time. The real problem is, can you get it to stop scratching the furniture? What are we about this? Can we get P1 to play fetch? P1 is a dog, and it's in a pet identifier. Can you do that? Wait, can dogs play fetch? Yes, dogs play fetch all the time. Of course, a lot of times they run, they get the ball, and then they leave the ball there, or you have to go chase them down. Pets are funny. Dogs are funny. Love dogs. All right, can you do that? Here's what happens. You get a compiler error. Why? Why do you get a compiler error? I thought you said, isn't P1 a dog? Yes, P1 is a dog, but the compiler, all it knows is that P1 is a pet. Okay, P1 is a pet. And so all the compiler is going to let you do is pet stuff. That's it. It'll only let you do pet stuff. It won't let you do dog stuff. So let's look at the next line. D1, make a sound. D1 is a dog. Can I make a sound? Well, make sound is a method that we find in the pet class. The compiler knows D1 is a dog. That's all it knows. Can it make a sound, which is a pet method? Yes, it can do that. Why? Because a dog inherits everything from its superclass, which is a pet. It gets everything from the pet for free. Okay, all pets get to make a sound. It just depends on which sound they make. Dog's going to go woof. Cat's going to go meow. All right, snail goes meow, whatever that is. If you watch SpongeBob, you know what I'm talking about. So D1 is a dog. It can make a sound, and that's fine. Now, before we had P1 play fetch. That failed because P1 is a pet. At compile time, it doesn't know that it can do any fetching. So can I do this at compile time? Can I cast it to a dog and then immediately do the dot operator on the casted basket, P1, which is a pet, and have it play fetch? Yes. Okay, because the runtime will say, hey, I know that P1 is actually a dog, so that succeeds. At compile time, it says, hey, I know it's possible for your pet to be a dog, so I'll let that go. And once you cast it, P1, to a dog, then you have access to all the dog methods, so then you can play fetch. So, awesome. Yes, you could do that. Did you get them? Okay, you want to go through them again on your own, and I want you to predict, but not only just memorize them, but know why. Why will you get an error at compile time or runtime? Okay, we've been talking about ISA a lot, but you know there's this concept of has a as well. So let's look at some of these things. For each of the following things below, the 6 things that we have below, I want you to tell me whether or not there's an is a relationship or a has a relationship. So let me give you an example. Down here below, we know that a subclass is a superclass. Okay, we just know that's going to happen. Another example is a cat is a pet, right? A cat is a pet. So the arrow goes from cat up to pet. Now a pet is a cat, is that true? No, that's not. The arrow goes in the wrong direction. So then here's another example. A face has a nose. A face isn't a nose, okay? We know that a face is not only a nose. We know that it has a nose. Everyone knows that. So I want you to look at the 6 examples here. I want you to tell me whether there's an is a or has a relationship and which way it goes. Pause. Restart. Okay, car, engine. A car has an engine. Okay, we know that an engine doesn't have a car isn't an engine, and an engine isn't a car. A car has an engine. Fruit and apple. An apple is a fruit. You don't want to go the opposite direction. You don't want to say a fruit is apple. Okay, an apple is a fruit. And we got person and lawyer. A lawyer is a person. Many of you may have said a person is a lawyer, but that's not always the case, right? A person cannot always be a lawyer. We know that all lawyers are people. Well, maybe not all of them, but in this case, all right, in this case, in our code example, we know that all lawyers are people. Okay, you may have met a lawyer or two that isn't, but or you suspect they're not, but in this code they are. TV and remote. TV has a remote. Bird and animal. A bird is an animal. Dining room set and table. A dining room set has a table. Why is this important? This is important when you design your concepts and you design your program and you start to get into abstract concepts. You're going to start to think about what things you have within your program. Some things, right, you want to abstract away, like a bird and an animal, and you want to know the relationship between the two, and you're going to tie them together. So as your code, it's good to know the relationships as you build your objects in your program to know what is a and what has a. So let's get back into coding with polymorphism. All right, this first line here, a variable of type t can hold an object of any subclass of t. That gets a little confusing. Like, what are you talking about? What we're trying to say here is that when I have something like an employee object and I assign it the value of a lawyer, what I've done is I've taken a subclass of employee, and it can hold any subclass of employee. A lawyer is an employee, a legal secretary is an employee. Both of these things will work just fine, okay? Not only that, but you can call only the methods in the employee class on the identifier ed. Ed is an employee, ed, okay? Ed, yeah. So I can only call employee methods on it. I cannot call lawyer methods on it. I cannot do sue, right? Because even though the lawyer can sue, the compiler only knows it as an employee. So down here, I can only do employee methods, which is get salary and get vacation. Those are the things that I can do. When it gets the salary, it's going to behave as a lawyer, and it's going to return $50,000 instead of the $40,000 that regular employees do. And when I call get vacation, it gives me 10 versus the regular employees, which I think is only 5. Okay, so we got polymorphism and parameters. So this is getting to the point like, Mr. Stride, why do I care about this polymorphism? Polymorphism you care about because it's probably one of the most powerful and important things in object-oriented program. It is where you get to do all the cool stuff. Here's an example of where you may want to use it. I'm going to create a lawyer, Lisa. I'm going to create a secretary, Steve. I'm going to print the info out for both of those. These are different types. Okay? They're both employees. A lawyer is an employee, a secretary is an employee. So when I print the info, I can pass that into the method printInfo, which takes as its formal argument an employee object. Employee. I passed a lawyer and I passed a secretary into an employee identifier. The employee points to the lawyer object, okay? The emple identifier. Okay, that's an amply good name. Emple is an employee, and in this case, When I call get salary, the first thing it does, when I passed it in with lawyer, it goes and gets the $50,000, and the vacation days is 15 days for the lawyer. Hey, how come on the previous slide it only did 10? That's not right. There's a bug. There's a bug. All right, 15 days for a lawyer, and then 10 days for a secretary. Okay, so V days for vacation days. Yeah, I wanted it to fit on the slide, you can tell. So when I call this, it's an employee, I can only call employee methods. That's all I have access to, but it will still behave like the object that it actually is. So it's going to behave like a secretary or a lawyer or a legal secretary or whatever it is. And that's polymorphism, that this same code that doesn't change, it looks the same, behaves differently depending on what the object actually is. It's so extremely powerful. Powerful! Okay, let's look at another example. I can take an array of objects. They all are employees. A new lawyer, a new secretary, a new marketer, a new legal secretary, all these things, and I can put them into a basket of a type employee. These are all subtypes of the supertype employee. So I got this backpack with lots of pockets in it, and I got in 4 pockets, I got lawyer, secretary, marketer, and legal secretary. It's cool that you can have 4 different things all in the same array. You can't argue with that. That is super, super cool. In one array, I got 4 different objects. They all are employees, which means on my E identifier, I can call any method that belongs to which class? The employee class. So I can call get secretary and get vacation days. So now I can run through my loop, I can go through my array, and I can call this on every single method in this object. Okay? Now, if I had the method take dictation right in here, would that work? Would that even compile? Did you discuss it? All right. The answer is it would not compile because take dictation belongs to the secretary class. And as we know, we definitely know this, that the compiler believes that every object is an employee and therefore will only do employee methods. If you wanted it to take dictation, you would have to explicitly cast it to a secretary so the compiler would let you do it. Polymorphism and arrays, those work all the well. That's one good way to use polymorphism. Now for those of you in my class, and if anyone's listening to this is not in my class, kudos to you. We're doing the TextExcel project. In TextExcel, we have an array, a 2-dimensional array of cells. And in those cells can be a number cell, a text cell, or a date cell. We have different types of cells in our cell array. That is powerful. So this is just another way we're trying to do it through the employee class. These outputs go different for each one. This is just showing that we run the code and it behaves differently for every single object. The first one's a lawyer. Well, you get it. All right, one more example of polymorphism here. We're going to have an Olympians that has a method. They know how to compete for victory. Then we have a curler. Okay, going out to you, Alex. We have a curler that is also an Olympian. Okay, so a curler is an Olympian. I would draw an arrow from curler to an Olympian. And they compete and they throw them stones. Okay, so then in my main, I can create an array of athletes that's going to hold 5 Olympians. I'm going to fill the array randomly with athletes, and then for every athlete, I'm going to have them compete. This code would totally, totally work. You don't have to know what's in your array at all. You just know that you're going to use this for each loop. Get an athlete A. It's going to call any athlete or any Olympian method, which at this case is only compete, and call that compete method. So to fill my array randomly, what I could do, if I so wanted to, is I could go through my length of my array, and then I would randomly pick either a new Olympian or a new curler, and I would assign that into my array. And since right here, are we doing value semantics or are we doing reference semantics? Yep, you nailed it. We got reference semantics. So when I change my array inside of here, it's going to change my array back here, which is why when I fill it in, I don't need to have it return the value. I don't need to assign the value into the array. All the values in the array are already changed because I'm using the reference semantics. I know you guys Wish you never had seen reference semantics before. But here it is again, okay? So this totally works. This method because curler is an Olympian, so I can put a curler into that athlete identifier and stuff that into my array. Very, very cool. I got one more example for you. I know you're dying to go. One more example. Here we go. I'm going to go to TextExcel. Those of you in my class, when do we use polymorphism in TextExcel? The answer is we do it when we print our matrix, when we print our cell values. So there's lots of ways to do this. I'm going to show you my method. You should have this totally working. This is the way I did it. I kind of think it's cool, which is why I landed with this one. Here's what I did. I have a render cell method. It takes whatever's in my cell and it's going to give it into a string that allows me to render what it is. It takes the row and the column as formal arguments in here. Then I'm using a string.format method that's going to format my string correctly to the right width. So I use the percent sign and then however long it needs to be. It's my cell width. If it's 10 wide, it's going to do 10 wide. I use the S and the pipe for my string format. When I do my format string right here, I send in the cell display and then it prints it at the correct width. That is super cool. String.format is a method that basically acts like printf. Very cool stuff. I asked the matrix to print itself. Give me the string that you're going to use to print itself. That will be, if it's a number cell, a text cell, or a date cell, it does not matter. It's going to print itself in the correct format, stuff that into cell display. Then I ask if the cell display length is greater than our cell width, we have to truncate it. Because string format doesn't truncate it, it'll only pad it. So if we were going to truncate it, we have to manually do that beforehand. Using this method for rendering cell is very, very cool, very slick. When I have that in there, it does not matter what type of cells I add to my program later on. I could add a monkey cell. I could add an octopus cell, okay? I could add a coronavirus cell, which is not really a cell. And it's going to go to string correctly. It's going to display itself. I can extend my code forever, adding new cells into my matrix without ever having to change this code. That's polymorphism. It's so cool. Okay, stare at this until you think it's cool, and then you may go.